Okay, let's look at the page 296 A4. It's another one of these prove the argument kind of problems. And notice that this one has no therefore in it. So it must be some kind of validity. It's a tautology in first order logic. So we should be able to prove it without any base assumptions. Now, it has a if and only if symbol in there, and if you look at the biconditional introduction rule, it means I have to start with one side, end at the other, start at the other side, end at the first, and so on. So it's kind of like showing, essentially we're showing that the left side and the right side are provably equivalent, but we're expressing that as an if and only if. Okay, but I mean the actual actions of doing so is exactly what you do to do biconditional rule. So let's go ahead and try. I haven't done this problem in advance, so we'll see where the pitfalls are. So if you think about the biconditional, first thing I need to do is decide one of the sides and then arrive at the other, and then vice versa. So in this problem, I'm going to start by assuming this in a subproof. I'm always allowed to assume whatever I want in a subproof, AX or BX. And I don't have to justify an assumption, I just do it. And I can't really do anything other than drop this existential quantifier. And when I do that, I have to pick a named constant that has not been used earlier in the proof. Maybe I'll pick, little c, and replace all the x's with the little c. Now, when I'm removing a quantifier, I also have to put that in a subproof. I apologize for not mentioning that. So existential elimination always occurs in a subproof. Let's look at the rule just to double check on it there. Yes. So if I have a there exists and I want to get rid of it, then I have to start a subproof and end at the thing I want, and that thing I end up with must not have that named constant I pick. So wherever I end up must not have the c in it. Now, thinking forward here, we're going to want to close this innermost subproof, out here, and we're going to want to get this statement that we want to end up with. And that's going to be the right-hand side of this biconditional. We want to end up here. Okay, so we'll see how that works. So we have now a subproof starting with, replacing the x's in line 1 with some named constant. Now, the strategy for any OR usually goes along this path, where I have to assume one of the halves get what I want, and assume the other half get what I want, and then get out. Now, what is it that I want at the end of this innermost subproof? Well, I want to get there exists x ax, or there exists x bx, because that's the thing that I'm trying to arrive at. Now, if I can arrive at that at the end of this statement, then I'll be able to pull it out and get it here. Now, why is that useful? Well, that's because that's half of my biconditional. So you see, it's all many levels deep, but it's all sort of going to come together. So I have this OR. I want to get at the end of this subproof this statement, and to do that in an OR, I'm going to have to get this statement twice, one for each of those assumptions. So let's give ourselves some room. I want to need to make an assumption inside here of A of C. And from that, I can certainly say there exists x ax, right? That's existential introduction on line 3. And now, looking at what I want, well, I can OR anything I want onto something. So I'm going to go ahead and I'm going to OR on. I'm going to put parentheses to emphasize it, but you don't really need the parentheses. It's going to be OR introduction on line 4. Now, I'm certainly allowed to do that because, well, it's OR introduction. You can OR anything you want onto something. It's a powerful technique. Now, again, I'm dealing with this disjunction. I've taken care of the first half of the disjunction. Now let me do the second half. It'll work very similarly. So I'm going to assume B of C, and I'll existentially quantify over C, and I'll get B. There exists X B of X out of that. There exists introduction on line 6. So that's line 7, and I can freely OR something else on the left. So I don't know how much room I'm going to need, so I'm trying to be conservative with my vertical lines there. And that's OR introduction on line 7. Okay, so if you look at the rule for disjunctions, disjunction elimination, I picked one half of that OR, I arrived somewhere. I picked the other half of the OR, I arrived somewhere. So here and here, here and here, these are the same. I know those parentheses make it look different, but it's the same. Then I'm able to conclude the thing that I concluded in each of the subproofs. So I can conclude from this, there exists XAX, or there exists XBX. And that is OR elimination. And I have to cite this to the disjunction in question, which is line 2. Then I have to cite the subproof that starts with the first of the two assumptions. So this subproof starting at 2 and ending at 5. Sorry, starting at 3 and ending at 5. And then the subproof starting at 6 and ending at 8. Okay, so what have we accomplished here? We've shown from this there exists statement, we removed the there exists, replaced the x with a constant, we got to a formula here, and that formula has no c in it anymore. By the rule of existential elimination that we saw earlier, we're able to pull that out. It meets all the qualifications. So I get this expression, and that's there exists elimination. Looks like a bug or something. Let's see how we have to cite that. I want to make sure I get it right. I think you cite the existential statement, then the subproof. Here it is. So I guess let's just look at it. We have this. Then we have the subproof that plugs a constant in for x. We arrived at some statement, and I'm pulling that statement out. And it's allowed. The constant does not appear. This constant doesn't appear up here. And the constant c didn't appear in the final formula we ended up with. And we never used any other constant, so there's no problem with like this assumption undischarged before line I issue. So if you look at the way it's cited, you cite the existential statement, then the subproof. So I have to cite line 1, and then the entire subproof from line 2 to line 9. And that will handle the first half of our biconditional that we're trying to prove. So now we want to go ahead and do the other half. So I'm going to do that on a separate sheet of paper. That way I have room. So I'll have this here to refer to if I need. So let's continue the proof. So we have our proof bar. We've just finished line 10, which said there exists XAX, or there exists XBX, and that was there exists elimination on 1 and 2 to 9. So that's the final line we had here at the end of the subproof from the left half of the biconditional. So now we have to go the other direction. We have to go from the, let's go back to the problem. We have to go from the right half of the biconditional to the left. So, 296. Okay, so now we have to assume this and arrive with this. So now we start a new subproof. I'm just going to give myself a bunch of room. And we're going to assume the right-hand side. We're going to assume, this statement. There exists x. The thing we ended up with, essentially. There exists x ax, or there exists x bx. So that's an assumption. Our goal is to arrive here. A single existentially quantified statement in front of the two ors. I mean, that really feels like factoring, right? I mean, it feels like I'm pulling this out. I'm pulling this out, and I'm sort of. I mean, it feels a lot like factoring. It is. It feels. I mean, it's some kind of logic factoring, right? Anyway, we can't really just use the law of algebra here. Algebra doesn't apply. We have rules of logic. Now, fundamentally, this is an OR. So I have to use the, this rule here. So I have to start assuming one side, ending up with what I want, and so on. So I'm going to make a subproof. And in that subproof, I'm going to assume there exists x ax. That's my assumption. Now, I need to get a single there exists in front of the or of both. So I need to remove this there exists to do anything. So existential elimination, just like we did earlier, I have to start a subproof. And that subproof takes whatever to the right of this, whatever's in the scope of this there exists operator, and replaces the x with some constant. Now, whatever I end up with in this subproof is what I'll be able to pull out if it follows the rules. So what I'm going to do is I'm going to take this thing and I'm going to OR something onto it. I'm going to OR B of C onto it. Now, why am I doing that? Well, if you look at where we want to end up, which is this statement, I have the same x in both positions. So it stands to reason that I would want the same named constant in both these positions, because with existential introduction, I'm free to replace as many of, including all of, or just one of, the constants that I'm, existentially quantifying over. So from here, I'm definitely welcome to write there exists x, ax, or bx. No problem. Well, that's great, because that's exactly what I want to get out of this thing. So I'm happy with that subproof, and so therefore I can conclude as a consequence of the assumption on line 12 that I can pull that out. So this thing comes out here. And I justify that. Oh, I guess I should justify some of these. This is OR introduction on line 13. This is existential introduction on line 14. And then this is existential elimination on the existential statement 12, followed with the subproof from 13 to 15. So that's line 16. Now, notice the left half of my OR is now completed. So my job going forward is to take the right half of the OR and arrive at the same statement. It's going to be a very similar kind of subproof. So let's see. Start a subproof. So assume there exists x bx. And so this is 17. And again, I'm going to have to start a subproof inside the subproof, where I replace the x in this existential statement with a constant. That's line 18. That's an assumption, because there's a horizontal line. And so now I can OR on the A of C that I want. So A of C or B of C. Again, that's or introduction on line 18. It's line 19. And now I can existentially quantify just like before. So there exists X, AX or BX. And that's line 20. And this is existential introduction on line 19. So now I've arrived at a statement that I'm allowed to use existential elimination on to pull it out, okay, of the subproof. So I get there exists X, I just copy it, right? AX or BX. That's line 21. That's existential elimination on line 17 and the subproof from 18 through 20. Okay, so let's look at what we have here. We have an assumption that's an OR. Main logical operator there is an OR. And that line's gone down the whole way. Now, we took the left side of that OR and we got this statement. And then we proved what we wanted to get out of it. We then took the right half of that thing and got this subproof, which arrived at the same exact thing as line 16. So I'm able to apply the disjunction elimination rule, because we've met this structure, and pull out from this inside of this subproof. I'm able to pull out and get this there exists statement that is what you could call it factored, right? So let's continue the proof over here. So let's see. Let me copy line 21 just to kind of keep it consistent here. So I've arrived at line 21. There exists X, AX or BX. And that's, let me not write the justification. Okay, so we've completed the disjunction part, and we've arrived at the same statement in both pieces. So therefore, we can end the subproof that starts here. So I shouldn't have drawn this line. So I'm ending the subproof. Wait a minute. Assuming this, I did the OR. Oh, I'm still in the subproof. Okay. So let's just get rid of that line and continue this down. So I can now say there exists X, AX, or BX, and that's OR elimination. And I have the OR from line 11. I have the subproof from 12 to 16, and I have the subproof from 17 through 21. And now look at what we've got. Okay. So notice that in disjunction elimination, the OR statement and the thing that you're concluding with are in the same level of subproof. So we have 1, 2 levels deep, and the OR in question 1 is 1, 2 levels deep. So they match. Okay, it's always good to do a sanity check there. So now, what do we have overall? Okay, so where'd my proof go? Ah, here it is. So our goal was to show this this bijection, this biconditional. The first page, we started with the left side, and we ended the proof with the right side. So we've shown that the left implies the right. On lines 11 through 22, we assumed this right here, and we arrived at this right here. So that subproof also, shows the other direction. So by the biconditional introduction rule, we can now say go out of level 2 back to level 1 and write the thing that we're trying to prove. We can write this entire thing. So there exists X, and then that's around both AX or BX. I don't have enough room to do it in one line, so let me do it in 2 lines. If and only if there exists X, AX, or there exists x bx. And that's a biconditional introduction, and according to that rule I need to cite two subproofs, I believe. Yes, the subproof that the first implies the second and the other way around. So the subproof that the first implies the second was the subproof from lines 1 to 10. Biconditional 1 to 10, and then the subproof from 11 to 22. And that will complete that proof. Now notice we had no assumptions, so that is a theorem of first order logic. It is a validity. It is just true, and we didn't have to assume anything to get that statement. So in some sense, at least with an OR, we've proved that existential operators sort of distribute in to an OR. Okay. Now, does it hold with an AND? Probably not, but with an OR it does.